In this example, we're going to use a scale of 20 millimetres to 1 Newton. As always, it doesn't matter which force we do first, but I'm going to do the 4 newtons. So 4 newtons at 20 millimetres to the newton means I need to draw the arrow 80 millimetres long. And as always, where that arrow ends, I draw the arrow for the second force. So using the protractor, you can see that the other force is at 20 degrees above the horizontal, going mainly to the left. So I'll put the protractor on there, start off from the horizontal, move round to 20 degrees, that gives me the direction. And then I need to get the correct length, so 5 newtons at 20 millimetres per newton means I need to draw the arrow 100 millimetres long. So there's my 5 newtons. And although we haven't met an example like this before, the rules are still the same. We draw the 2 arrows for the separate vectors, and to find the resultant, we go back to the starting point and we draw the arrow that takes us direct to the end of our last vector that we drew. So from here up to the end point, and that is our resultant vector, resultant force. So we can measure the length of the arrow, which is 36 millimetres long. It's 20 millimetres for each newton. So as if I couldn't do it in my head, it would be 36 divided by 20, which will give me a resultant of 1.8 newtons. Of course, I could do it in my head. And this, of course, is an example of a situation where you add together 2 forces and the resultant is a force that's smaller than either of them. Which, when you look at the diagram, you can see that they are sort of tending to pull against each other. So a lot of the effect does seem to be cancelled out, which is why the resultant is only a small force.